Yeah, so covalent bonding simply means that the co part means sharing and the valent part means last shell. So it basically means that the electrons from last shell are being shared. So covalent bonding is when sharing of electrons from last shells. But what shares them? Basically, both atoms, both the atoms involved, they do this. But here's the thing, bonding we know is based on forces of attraction. It's not based on how it came about. Obviously, it's important to know. हमने ionic पे कहा था that ionic bonding is when the electrostatic force of attraction between negative and positive ions. But obviously, the history was that those ions were made when transfer of electron was done. When electrons went from a positive, from any metal to a non-metal. In this case, we took the example of sodium chloride, and we said sodium gave one electron to each chlorine atom, making sodium ion, chloride ion. So that was how it came about. But the bonding itself was simply a strong force. So bonding is nothing but strong force. So in the case of ionic, we said it is strong electrostatic force. What is it in the case of covalent bond? So the thing is, when we say that we are sharing electrons, so we are basically using a symbol or a diagram which is like this. So we have two atoms which are overlapping each other. And what happens is that, let's suppose I have hydrogen. So this hydrogen atom will share some area with the other hydrogen atom. And in that area, it's going to share electrons. And in the case of hydrogen, it will be one pair of electrons. I'll talk about why it is one pair and when is it not one pair. So here's the thing. This is one pair of electrons. Now let's see how it came. What is attracting it? So this hydrogen nucleus is attracting both of these electrons. And this hydrogen at nucleus is also attracting both of these electrons. And this attraction is covalent bond. So if you were to define covalent bond, it will be the strong force of attraction between shared pair of electrons and the two nuclei. Nuclei is basically plural form of nucleus. So both of these nuclei are attracting this shared pair. So this shared pair is important. And remember, the covalent bond always happens when electrons are shared. Now, one more thing. Earlier on, when this atom was on its own, the electron could move around anywhere it wanted. But now both of these electrons are restricted in the space between the two nuclei. अब वो उठ के कहीं और नहीं जा सकता. It is restricted because it's being attracted by both sides. So that keeps it in balance, and that is why this is very strong force, because दोनों उसको pull करें. Secondly, both of these electrons, they are called bond pair. Okay? Both of these electrons are part of a bond pair. These are what makes a covalent bond. And this diagram, we write it as dot and cross structure. So basically, we can show covalent bonding as a dot and cross structure. So let's see, how do we know how to draw dot and cross structure? So I'll talk about that now. So I'm going to write some of these. So in the case of hydrogen, you can see that hydrogen atoms have shared one electron. लेकिन अब इसमें बात ये है कि how do we know कि इन्होंने एक electron share करना है? So for that, just imagine how many electrons does hydrogen have in the last shell? So it has one, right? And that is the first shell, which means it needs one more to complete it. Remember, the bonding is being done so that they're stable. And to make a shell stable, you need to give it 0, 8, or full shell, right? So yahan par, if you give it one more electron, it becomes full. But the problem is it's not interested in losing or gaining. It wants to share because the other one is also not interested in losing and gaining. So when they share, we look at, okay, how many does the first one want to share? It needs one more, so it will share one. And the other one also needs one more, so it will also share one. So what happens is we draw these circles. So one circle for one hydrogen and the other circle for the other hydrogen. And then we put the names in the center. So this hydrogen, we write H, this hydrogen, we write H. Do not put circles here for the nucleus. Just write the symbol of that thing. Now, this hydrogen needs one more, so we'll put its own electron and the other electron. Remember, ये electrons एक जैसी हैं. ये नहीं है कि उनकी shapes different है. They are identical electrons. Just to show that one is from the left hydrogen, one is from the right hydrogen, we use different symbols. So this is one bond pair of electrons. Now, both of these hydrogens think that they have a complete shell. Because come to think of it, इस हाइड्रोजन के शेल में दो इलेक्ट्रॉन्स हैं, उस हाइड्रोजन के शेल में भी दो इलेक्ट्रॉन्स हैं, तो दोनों को लगता है कि हमारा शेल कंप्लीट हो गया. And that is why they stay together. And then there is the strong force pulling on this pair from this nucleus as well as from this nucleus. तो उसकी वजह से वो intact रहते हैं. There's another way we can make this diagram. That is called a Louis diagram. Some also call it caie structure, but मतलब इसका दूसरा नाम caie structure. It is really simple. You put both the nuclei, and because they have one pair, we put one line in them. So this line basically shows one bond pair. Okay, so that is what this line shows. And how do we write them? Another way to show that is a formula. The formula basically tells me how many hydrogen atoms are joined together. So we have hydrogen, and how many of them? Two of them. So this two over here tells me that they are chemically bonded. Remember, अगर ये two यहाँ पर आ जाएगा तो इसका मतलब है कि they are not bonded. So these show not bonded. Two atoms not bonded. This one shows two atoms bonded. Okay, so the number here and the number placement plays an important role in telling us whether it is bonded or not. Take out notebooks. We are going to draw all three of these for different elements and then for some compound. So the next element is chlorine that we want to talk about. Now chlorine is in the last shell. Oh, sorry, it's in the group 7, which means it has 7 electrons in the last shell. What that means is that if you look at chlorine, तो chlorine का structure कुछ ऐसा होगा कि you have last shell in which there is 7 electrons of its own and needs one more. So this is chlorine. This is also chlorine. Chlorine has 7 electrons. How many more does it need? One more. So it will share one. Remember, जितने चाहिए usually उतने ही share करने पड़ते हैं. So इसको एक चाहिए, ये एक share कर लेता है. Now it had 7 to begin with, right? So one it has shared, the other 6 are outside. They're not part of the bond. One more thing, whenever you draw these structures, again, you will not lose marks for this, but don't put them independently. आप हमेशा pairs की form में electrons को लिखें. Put 2 electrons together if you can. Don't put them one at a time. Okay? So avoid writing something like इस तरह नहीं बनाए. Put them the way they are done on the left side. Although दोनों sides पर equal number of electrons हैं, but this is usually the preferred way. And why is that? Because electrons always exist as pairs. This thing, the electron pair that is not involved in bonding, this is called lone pair. Okay, so we have two kinds of electron pairs in the last shell. One is bond pair, the one that is in the middle, and one is lone pair. Now let's draw its Louis diagram. So for that, just put Cl, another Cl, and there's a straight line in them. And this line is because they have one bond pair. जितने bond pairs होंगे, उतनी lines होंगी. All right, so here's how it goes. It will actually be exactly like chlorine because chlorine and fluorine are in the same shell. So we'll have two like atoms that are joined together like this, and they will be F here, and they are both in the 7th shell. That means that you just need one more electron. So one pair is shared, and they have 6 electrons left. 7 में से एक share हो गया ना? So 1, 2, 3, 4, 5, 6 for this, and 1, 2, 3, 4, 5, 6 for this. And the Lewis structure will be just this. Now let's do it for oxygen. Oxygen is in group 6, which means it needs 2 more electrons. So that's how oxygen will share its electrons. It needs two more, so it's going to share two electrons, and that is because it needs two more, so do share kar legi. And you'll get oxygen here, and they will have four left over. Out of six, they've shared two, the leftover are four, so we put them as pairs like this. Similarly, when we are drawing the Lewis structure, we will put two lines there to represent that we have two bond pairs. Every line is for one bond pair. I would suggest that you do the same thing for N2 when you can. Similarly, we can use it to represent different molecules of compounds. So how does that work? For simple molecules, you just have to look at the formula to figure out कि कितने atoms होंगे और कौन से atoms होंगे. So let's suppose we have HCl, which is a very simple one. Let's say HF. That means we have two atoms, but one is for hydrogen and one is for fluorine. So वो दोनों हम ऐसे ही share कर देंगे. Okay. And they both have to see किसको कितने इलेक्ट्रॉन चाहिए. तो हाइड्रोजन ये है, फ्लोरीन ये है. हाइड्रोजन needs one more, fluorine needs one more. They will simply share one. और हाइड्रोजन के पास एक ही था, वो उसने शेयर कर दिया. So no electrons outside, no lone pairs. Fluorine had 7 electrons. One is shared, then it will have 6 that are not shared. So we put them on the outside. It does not matter what you use, what symbol you use. You can put circles or you can put crosses. लेकिन squares नहीं बनाने, कोई stars नहीं बनाने, कोई और symbol नहीं बनाना. It's always circles or crosses to show the dot and cross structure. Similarly, we will have one lone pair, so one bond pair, so that is why there is one line. Things get a little more interesting when you have more than two atoms. So far, we have only dealt with what we call diatomic molecules. Remember this term, diatomic molecules. Diatomic means that they're made from two atoms, and you can see that there are two circles to represent both of those atoms. Now we're moving forward and we're talking about atoms combining together in more than two. So here's how it goes. Let's suppose we have carbon dioxide. How do we draw a structure like this? We have three atoms. So whenever we have these things, we usually look at a central atom, जो इन दोनों के बीच में होगा, इन तीनों के बीच में होगा. And for that, we have to look at how many electrons do they need. So carbon, it is in group 4. So placement in periodic table is important. Carbon is in group 4, which means it needs 4 electrons. Oxygen is in group 6, which means it needs 2 electrons. So ज़्यादा किसको चाहिए? Carbon को ज़्यादा चाहिए. ठीक है? So pay attention. Remember, the one that needs more electrons goes in the center. So over here, we will have carbon going in the center. And we will have oxygen on one side. Sorry. Yeah. Hold on. I don't know. Yeah. So we have oxygen on one side and another oxygen on the other side. And carbon is in the center. Okay. Now we start with the outside ones. So this oxygen, it needs 2 more electrons. So it will share 2. So out of 6 that it has, 2 are shared and 4 are outside. Similarly, this oxygen here, it needs 2 more. So it will share 2 and 4 will be left over. And then we look at carbon. Carbon had 4. It has already shared 4. So it doesn't need to put any more. So that's it. We are done. Now, common mistake here is that students think that, okay, sharing वाले तो हो गए हैं, लेकिन इसके पास थे तो 4, तो वो 4 electrons ऐसे बना देंगे. But remember, that is wrong, because you have to know that all that they share come from the valence electron that they already have. तो अगर उसके बाद 4 थे, 4 share हो गए, तो पीछे कुछ भी नहीं बचा. No lone pairs. How do we draw the Lewis structure? We put them in the order that they are, and we show lines to show bond pairs. Carbon and oxygen have 2 bond pairs, so that is this. This bond is called a double covalent bond because it is using 2 bond pairs. This one is called a single covalent bond because it is using 1 bond pair. But remember, in one molecule of carbon and oxygen, we have 1 bond here, we have second bond here. We will say we have two carbon oxygen double bonds. Okay. So that's important to understand how many bonds there are and what kind of bonds there are. Later on, we will talk about a topic, enthalpy changes, in which we will discuss the energy involved here. Remember that every time we have a bond, that bond is basically, it holds some energy inside it. It's like a storage of energy. So you need to supply that same energy to break the bond. So this double bond will be much stronger than if you had carbon oxygen single bond, because the bond energy in the double bond is stronger than the bond energy of single bond. Similarly, if we have more than three atoms, even let's suppose we have NH3, then we will again discuss किसको ज़्यादा चाहिए, वो center में आएगा. So nitrogen needs 3 more electrons because it's in group 5. And hydrogen just needs 1 more electron. So what happens is that nitrogen goes in the center. And we have 3 hydrogen on the side. Now you don't have to draw them of the same size. आप छोटा भी कर सकते हैं, doesn't really matter. ठीक है? तो हम different circles बना देंगे to show that these are different atoms. Then we will put the names there. So nitrogen here, hydrogen here, hydrogen here, and hydrogen here. And the names come from the fact that hydrogen needs 1 electron, so it is on the outside, and nitrogen needs 3 electrons, so it is in the center. So बाकी तीनों hydrogen side पे. How do I know मैंने 3 hydrogen बनाने? I look at the number here. H3 means I have 3 hydrogen atoms that are bonded. Okay, N के साथ number नहीं है, that means 1 nitrogen atom. So here's how it goes. We look at hydrogen, it needs 1 more electron. We put 1 electron pair here because it has shared 1 electrons. Now, similarly, this hydrogen needs 1 electron. It will share 1 electron, same as nitrogen. And this also needs 1 more electron. It will share 1 electron. Hydrogen के पास एक ही होता है, no lone pairs. Now let's talk about nitrogen. Nitrogen has 5 electrons. 1, 2, 3. All 3 have been shared. The leftover is just 2 electrons which go here. NH3. We have made it. Now this thing, its Lewis structure will be, you just draw it like this. Now it doesn't matter. Sometimes students think that we can put it like this. And remember, it's perfectly fine. As long as you have 3 hydrogens joined together, it's perfectly fine. कि आप ऊपर बनाएं, नीचे बनाएं, left पे बनाएं, it's totally your choice. Doesn't really make a difference. Because molecules भी तो घूम रहे होते हैं. So I'm going to share a worksheet with you and I would like you to solve it by drawing these different structures and different shapes. So ये तो हमें समझ आ गई कि उसमें structure है, उसमें shares हैं. अब यहाँ पे bonding कहाँ पे है? This nitrogen is sharing this electron pair with this hydrogen, तो ये एक covalent bond है. This nitrogen is sharing 1 pair with this hydrogen, ये दूसरी covalent bond है. और ये तीसरी covalent bond है. So the covalent bonding is actually the forces that are very strong and that are inside the molecule. But covalent bonding में एक और चीज भी होती है. Now, how does a covalent substance behave? So covalent molecule तो हमने देख लिया. This whole thing is a molecule. How does the covalent substance behave? So I'm going to talk about simple molecular structure here, simple molecular substances here. Just like ionic and covalent, ionic and metallic bonding, I'm going to give you a theory and we're going to discuss the properties of these things and see if the theory explains it. So what are properties of simple molecular substances? Let's suppose ammonia or water, we take that as an example. Then ammonia has a low melting point. Ammonia, if you have solid ammonia, it is brittle, which means it breaks easily. Similarly, these things do not conduct electricity, which means they are bad conductor. Now, how does the simple molecular substances theory explain this? Let's see. So what does the theory say? The theory says that once you have gotten the molecule, so एक molecule ये, एक molecule ये, एक molecule ये, these molecules have very weak forces between them. So weak intermolecular forces of attraction. ठीक है? I'm going to call them IMFA. Just like electrostatic forces were EFA, this is IMFA. These are weak forces. Another way name these have is called van der Waals forces. ठीक है? So इनको आप van der Waals forces of attraction भी कह सकते हैं, intermolecular force of attraction भी कह सकते हैं, because they are between different molecules. Remember, covalent bond नहीं है ये. Covalent bond तो वो molecule के अंदर हाइड्रोजन नाइट्रोजन की थी ना, if you take the example of ammonia. But van der Waals forces are the way one ammonia molecule attracts another ammonia molecule. And these are weak. What are they between? Between molecules. Let's try to make sense of this. So what is the forces? Weak intermolecular forces. What are the particles? Molecules here. Okay? और इसका structure क्या होगा? कोई structure fix नहीं है इसका. So let's try to explain the properties that they have. They have low melting point. Obviously they have low melting point because they have weak intermolecular force of attraction. They're brittle, they break easily. Because again, weak force of attraction, you can break it with strong, with even with low energy, you can melt it with even low energy. And they don't conduct electricity. क्यों नहीं करते? No free electrons. या तो electron is part of a bond pair or it is a part of a lone pair. In either case, it's not free. So इस तरह से no free electrons. So obviously it does not conduct electricity no matter what. ना वो पानी में डिसॉल्व होके करेगा, ना वो लिक्विड के तौर पे करेगा, ना वो बॉयल होके करेगा. A covalent substance cannot conduct electricity like this because उसके अंदर free electrons है ही नहीं. But यहाँ पे सवाल ये आता है कि there are some covalent substances that do conduct electron, like acids or pure water or water. So acids and water, they conduct electricity, right? But here's the thing. Pure acid and pure water cannot conduct electricity. They can only conduct electricity when ionized. And remember one thing, these can never be pure and ionize. They have to be impure. So they ionize. क्योंकि जब वो ionize हो जाते हैं तब उनके पास free ions आ जाते हैं जिसकी वजह से they can conduct electrons. They can conduct electricity. Okay? So remember this, that unless they ionize, these simple molecular substances cannot conduct electricity. और उसकी वजह बड़ी सिंपल सी है, उनके पास कोई free electron है ही नहीं. But here's the thing, not all molecules act like this. ये तो molecules हैं, ये इस तरह से behave करते हैं. इनके पास free electrons नहीं होते, इनके अंदर बीच की weak forces of attraction होती हैं, और इनके particles वो molecules हैं which are independent of each other, जिनको हम dot and cross structure से बनाते हैं. But there are another kind of molecules that are quite opposite to this, and those are called macromolecular substances. Another name that they have is giant covalent structures. So let's see, how are they different? So giant covalent structures में a classic example is that of diamond. So you know diamond, it is carbon atoms joined with other carbon atoms. But the problem with that is कि यहाँ पर हमने देखा था नाइट्रोजन नाइट्रोजन से ज्वाइन हो रहा है, ऑक्सीजन ऑक्सीजन से ज्वाइन हो रहा है, फ्लोरीन फ्लोरीन से ज्वाइन हो रहा है, because they're sharing electron, they're able to do that. With carbon, it is not possible because carbon needs 4 electrons. So when carbon tries to share 4 electrons with the other carbon atom, the force between that electron, वो एक दूसरे को इतने जोर से push away करते हैं क्योंकि you know electrons are negative. यहाँ पे आप देखो कि हाइड्रोजन फ्लोरीन ने जो शेयर किए हैं ये दोनों इलेक्ट्रॉन एक दूसरे को पुश कर रहे होंगे ना, लेकिन न्यूक्लियस की फोर्स से वो वहीं पे बैठे रहते हैं. यहाँ पर ऑक्सीजन के दोनों बॉन्ड पेयर्स एक दूसरे को पुश अवे कर रहे होंगे बिकॉज दे आर नेगेटिव, But oxygen molecules जो nucleus है उसके अंदर, they are able to keep them in that small space. But when it comes to carbon, carbon has 4 electrons that it wants to share. So 8 electrons share करना और उनको एक छोटी सी जगह पे confine करना, it's quite impossible. So what does it do? Instead of sharing 4 electrons, it shares 1 electron with one atom, one with another atom, one with another atom, and one with another atom, making something like this. So this is a carbon atom. It shares one with this one with another, one with another, and one with another. And that way, it forms what is called a tetrahedral structure. Tetrahedral क्यों है? क्योंकि आप इसको देखो, यहाँ पर हमारे पास ऐसे 4 कॉर्नर्स बन गए हैं इसके. तो ये टेट्राहीड्रल स्ट्रक्चर है बिकॉज दिस इज मेड ऑफ 4 sides. ठीक है? So this is tetrahedral structure. Now here's how it goes. Because carbon has shared these 4 bonds with 4 different atoms, तो कार्बन के पास अब बहुत बड़ा सा स्ट्रक्चर बन जाता है. So let me show you. Sorry, डायमंड के पास एक बहुत बड़ा सा स्ट्रक्चर बन जाता है. So I'm going to copy this here. So यहाँ पर आप देखो, ये डायमंड है, राइट साइड पे आप देखो. Every ball there is supposed to be a carbon atom. But what happens is that this carbon atom, it has shared an electron with another carbon atom, which has shared an electron with another carbon atom. लेकिन बात ये है कि वो कब तक शेयरिंग करेंगे? They will keep on sharing because this carbon, it has shared with 1, 2, 3, 4. And that one also needs to share. So 1, 2, 3, 4. And that one also needs to share. So 1, 2, 3, 4. So that way, every carbon atom is sharing electrons with 4 other carbon atoms. And those 4 are sharing with 4 others. And that way, they keep on continuing. और हमारे पास एक बहुत बड़ी लैटिस बन जाती है. So यहाँ पर this is an atomic lattice. ठीक है? All right. So we have a strong atomic lattice. Sorry, where did it go? Remember, lattice is simply a repeated structure. So we have a large atomic lattice. उस atomic lattice के अंदर strong forces of attraction है. Every atom is attracting the other atom. Now let's see, how does diamond behave? Diamond is hard. Diamond has a high melting point. Diamond is a bad conductor. And why are we able to use this theory to explain it? Because you see, lattice है, every atom is attached to another atom, जिसका मतलब है strong forces हैं. उन strong forces की वजह से it is hard. उन्हीं की वजह से it has a high melting point. And it's a bad conductor because you see, all electrons are involved in bonding, so no free electrons. So that's how it goes. That diamond, which is a form of a giant covalent structure, and diamond is not the only one. Silicon dioxide also behaves in a similar manner. Here's the structure of silicon dioxide. You can see over here that for every silicon atom, we have 2 oxygen atoms, silicon dioxide. But that does not mean that we have 1 silicon and 2 oxygen. This is very different from the molecule. Because molecule में जब हम कहते थे CO2 तो हम उसका मतलब होता था 1 कार्बन और 2 ऑक्सीजन. But यहाँ पर, because we have a lattice, we are not saying that we have 1 silicon and we have 2 oxygen. We are basically saying the ratio is this. So remember, जब भी lattice होगी, हमें ratio मिलेगी. So this is ratio. Because it's a lattice. जब lattice नहीं होती, तब हमें actual atoms का पता चलता है. So this is again a large lattice which is made by strong forces of attraction between these different atoms. उनके बीच में bonds हैं. Now graphite is an exception to all this. Graphite is a mix, it has hybrid qualities. How does graphite behave? So let me show you. This graphite, what happens is that every atom here, it is attached to one hair, one hair, one hair. This atom here is attached to 1, 2, 3. This is attached to 1, 2, 3. Every carbon atom in here is attached to 3 others. But उसकी यहां पर भी देखे ना, ये 3 के साथ तो ज्वाइन हुआ हुआ है, लेकिन वो जो एक ऊपर वाले के साथ उसने ज्वाइन होना है, उसके लिए उसके पास ग्रेफाइट के पास एनर्जी नहीं है, वरना ग्रेफाइट भी डायमंड बन जाए. एंड दैट एक्चुअली हैपेंस. ग्रेफाइट डज बिकम डायमंड इफ यू गिव इट अ लॉट ऑफ एनर्जी. But right now, as graphite, it doesn't have that energy. So it just makes do with these layers. So ये एक layer ऊपर वाली रहेगी, ये नीचे वाली layer है, ये उसके नीचे वाली layer है. And you can see these dotted lines which show that you have peak forces. And by the way, how many electrons does graphite have? The carbon atom has 4 electrons, right? So इसके पास एक तो इधर बॉन्ड हो गया, एक इधर बॉन्ड हो गया, तीसरा इधर बॉन्ड हो गया, फोर्थ इलेक्ट्रॉन इज फ्री. सो फ्री इलेक्ट्रॉन्स. सो उस वजह से इट स्टार्ट्स टू conduct electricity, which is why graphite is a good conductor, because it has one free electron. Diamond मेरे पास नहीं था, इसके पास है. Graphite diamond बन जाएगा if you give it a lot of energy, but right now it doesn't have that. Similarly, these are layers. If you remember from metallic bonding, we saw that layers make things soft. Layers can
Sir,
slide over each other. Yes, Zen?
sir, I don't really get why graphite would conduct electrical charge.
Very simple. Every carbon atom has 4 electrons in the last shell, right? But in case of graphite, 3 of them have been shared. Now, I told you that electrons try to either become lone pairs or bond pairs. तो अब वो जो फोर्थ इलेक्ट्रॉन है वो तो अकेला है, ना वो बॉन्ड पेयर है ना वो लोन पेयर है, वो फ्री है, जिसकी वजह से अब वो बिजली कंडक्ट कर सकता है. लेकिन
सर
वो
अगर
कैसे कंडक्ट करेगा?
सर अगर लोन पेयर होता तो वो इलेक्ट्रिसिटी कंडक्ट नहीं कर सकता.
नहीं कर सकता. अगर लोन पेयर होता तो फिर तो वो एटम के अंदर रह जाता. यहाँ पे ना वो लोन पेयर है ना वो बॉन्ड पेयर है. सो अब वो क्या करेगा? अब वो कंडक्ट करेगा, लेकिन किस तरह? वो इस लेयर के यहाँ पर अगर एक इलेक्ट्रॉन है तो इधर घूम जाएगा, वो इधर घूम जाएगा, लेकिन वो लेयर के अंदर से घुस के नहीं जा सकता बाहर. इट विल ओनली कंडक्ट व्हेन इट्स मूविंग ऑन द लेयर. किसी और डायरेक्शन में नहीं मूव कर सकता वो. द डायरेक्शन ऑफ कंडक्शन इज एन इंपॉर्टेंट फॉर ओ लेवल्स और IGCSE, बट आई एम जस्ट टेलिंग यू that this is how the electrons will behave. Now, these properties give them different uses. So here's how it goes. Here are some uses, and you have to tell me why graphite and diamond are useful for that. So diamond का एक use है that it is used in drill bits, which means that you can use it to cut marble, you can use it to cut other diamonds, you can use it to cut, to etch on metal. Diamond use होता है. Similarly, graphite is used to make electric rods, जिनको हम electrode कहते हैं. And graphite is used to make, it is used as a lubricant. It is used in pencils. You have to explain why diamond is useful as a drill bit, why graphite is useful for these 3 things. So go on. What structure or what property of diamond tells you that it is useful as a drill bit?
Hard. It is hard.
It is hard. And why is it hard? It is hard because it has strong forces that keep things the way they are. वो उनको बेंड नहीं होने देती, वो उनको स्लाइड नहीं करने देती, वो उनको मूव नहीं करने देती, उनको फिक्स करके रखती. So those strong forces between these atoms in the lattice, that is what makes them hard. Okay. Graphite is useful as an electrode. Why is that?
It can conduct electricity.
Very good. It can conduct electricity and it is cheap. 2 reasons. Okay. Why is it useful as a lubricant?
Because of high melting point.
नहीं, melting point का lubricant से क्या ताल्लुक है?
Sir, it is soft.
It is soft. लेकिन वो soft क्यों है?
सर वो लेयर्स है उसके ऊपर, लेयर्स के इसी वजह से सर इट कैन
तो वो
स्लाइड.
लेयर्स क्या करती हैं? लेयर्स कैन स्लाइड. वो लेयर्स स्लाइड क्यों कर सकती हैं?
तो उनके अंदर एक वन फ्री इलेक्ट्रॉन होता है, आयन.
वेरी गुड.
सर आयन कहूँगा कि इलेक्ट्रॉन कहूँगा सर?
इलेक्ट्रॉन होगा, क्योंकि यहाँ पे कोई भी आयंस नहीं है. ओके, ऑलराइट. नाउ पेंसिल्स में इसको क्यों यूज करते हैं?
सर इसको शेप इसकी बदल सकते हैं इसीलिए मेरे
नहीं,
ख्याल में।
शेप तो आप किसी भी चीज की बदल सकते हैं मोस्टली। तो
सर डायमंड की
डायमंड
तो
की भी
नहीं बदल
शेप होती
सकते।
है, डायमंड को भी कट करके उसकी शेप्स बनाते हैं।
अच्छा
That is
ठीक।
what makes it more beautiful or shiny. Otherwise, though, it's a useless piece of rock. I just saw these. So basically, these graphite layers, they can, they are soft ना, उनके बीच में forces भी नहीं है. तो when you slide them on paper, तो many layers simply drop down. So let's suppose आपने एक pencil पकड़ी, you were drawing something on paper. So every time you apply a little bit of force, maybe 40, 50,000 of those layers simply drop down on paper and stay there. And the second reason we use graphite is because it has a dark black color. It is soft, तो आप इसको slide कर सकते हो without applying a lot of energy. And secondly, it is dark black इस वजह से. Thirdly,
सर
it is mostly insoluble. और वो insoluble क्यों है? कोई भी चीज डिसॉल्व क्यों करती है? क्योंकि वो सॉल्वेंट के साथ फोर्सेस बना लेती है। ठीक है, जैसे ग्रेफाइट अगर पानी में डिसॉल्व नहीं होता तो उसकी वजह यह है कि पानी के मॉलिक्यूल्स ग्रेफाइट की बॉन्ड्स को तोड़ ही नहीं सकते। जब वो तोड़ ही नहीं पाएंगे तो नई बॉन्ड्स ही नहीं बनेंगी और ग्रेफाइट डिसॉल्व नहीं होगा। सोडियम क्लोराइड डिसॉल्व हो जाता है बिकॉज वाटर मॉलिक्यूल्स कैन ब्रेक द बॉन्ड्स इन सोडियम क्लोराइड एंड मेक न्यू बॉन्ड्स विद सोडियम, which is why it dissolves. ग्रेफाइट की अपने अंदर इतनी स्ट्रॉन्ग फोर्सेस हैं कि उसको कोई चीज तोड़ ही नहीं सकती, which is why it doesn't dissolve, not in water, not in alcohol, not in most any solvent that I've heard of. It cannot dissolve graphite. Now here's another idea. If the electron is free, so why doesn't graphite form covalent bond? Oh sorry, ionic bond. अगर वो फ्री ही है तो वो उसको दे दे किसी और को. But the problem with that is that carbon needs 4 electrons still. वो फ्री तो है लेकिन if it wants it back anytime it still can. वो अभी भी पूरी तरह स्टेबल नहीं है. It wants to make a fourth bond, which is why graphite, given the chance, it will make that. ठीक है? So it cannot form ionic bonding right away.
सर ये फिर से एक्सप्लेन कर दे सर।
Point is that right now it is charge neutral. It has zero charge because the number of electrons and protons is the same. And graphite has 3 bonds made और fourth के लिए these electrons are free. They are trying to move. इसका मतलब क्या हुआ कि उसके शेल में अभी 6 इलेक्ट्रॉन्स हैं जो कि बॉन्डेड हैं और 1 इलेक्ट्रॉन है जो कि फ्री है. It's trying to look for another way to make that bond. So it cannot really lose that electron. It will make it unstable. Right now it is stable because it's still looking for a bond and all that. But अगर आप एक नया इलेक्ट्रॉन ढूंढने की कोशिश, अगर आप इससे इलेक्ट्रॉन छीन लेंगे, so it will become unstable, इसके ऊपर चार्ज आ जाएगा, तो वो ये नहीं करता, which is why carbon doesn't form ionic bond. Another way to think of this, that why doesn't it form ionic bond, is कि आप imagine इस तरह से कर लें कि for a very short amount of time, because of these dotted lines, these carbon atoms feel that they have a bond between them. Very short amount of time, because वो electron free है तो वो move करता रहता है. But for a moment, उनको लगता है कि हमारे बीच में कोई force है, कोई bond है, तो हम stable हैं. So we are done with chemical bonding. Very important chapter. Just remember, the main weight or the mantra to covalent bonding is trying to understand 3 things of the substance: the forces, the particles, and the structure. ठीक है, तो हमने मेटेलिक में स्ट्रक्चर देखा था कि लेयर्स हैं, कैटाइंस हैं और फ्री इलेक्ट्रॉन्स हैं जिनमें स्ट्रॉन्ग EFA है. फिर हमने उससे उनकी प्रॉपर्टीज को एक्सप्लेन किया था. जब भी एग्जाम में क्वेश्चन आता है वो प्रॉपर्टी देगा, रीजन मांगेगा, या वो रीजन देगा, प्रॉपर्टी मांगेगा. ठीक है, आयनिक बॉन्डिंग में भी आपने स्ट्रक्चर देखना है कि वो लैटिस है, पार्टिकल्स हैं, फोर्सेस हैं. कोवेलेंट में भी स्ट्रक्चर है, वो कभी मॉलिक्यूलर स्ट्रक्चर है जिसकी डॉट एंड क्रॉस डायग्राम बना सकते हैं, जिसके अंदर फोर्सेस वीक हैं और पार्टिकल्स आर मॉलिक्यूल्स जिनके अपने अपनी प्रॉपर्टीज हैं. और सिमिलरली मैक्रो मॉलिक्यूलर के अपने स्ट्रक्चर्स हैं और वो स्ट्रक्चर जो हैं दे टेल अस हाउ दैट थिंग विल बिहेव. ओके, दैट्स इट.